Hi, we are in chapter 15, which is impulse and momentum. So this problem, we have a 80 pounds person or man that is in a boat. The boat has a mass of 120 kilograms, and he will throw a box. So we are neglecting the resistance of the water. So whenever he throws a boat, since there is no force that stops the boat will go backwards. And they are asking us to find how far does the boat move after a certain amount of time, 3 seconds. So we will consider first, before we are able to find the distance, we will consider the velocity that the boat gains when he throws the box. So if he would have been on the floor, the velocity that he throws the box will be an absolute velocity. Since he is inside the boat, this is a relative velocity. To boat. What we are going to do is using the principle, impulse and momentum. To do that, we draw diagrams of impulse, or impact diagram or impulse diagram. And I will draw the impulse diagram with the guy with the box together. So as soon as he throws the box, he was creating an impulse to the box, and the box is creating an impulse back to the boy, the man, the same amount. So if I draw the whole impulse, the whole system together with the guy holding the box right here, so, and the water doesn't create any resistance, so we have the only impulse that are creating is the impulse that he gives to the box, and the box created back to the boy. So here we would have impulse, but that impulse will cancel with that one. So those are internal forces, therefore I do not draw it. Let me erase them. So if we do the principle of impulse and momentum, we will draw that all the forces will be to the mass of all the elements in the position 2, which is after he throws the ball, minus the position right before he throws the ball. And that will be, so if we don't have any impulses, that will be equals to 0. And right before he throws the box, there is no velocity. We can say that this is 0 as well. So what we have here, this is equals to 0, and we will have here what? We will have the mass of the box, the velocity of the box after he throws it, plus the mass of the boat and the men together, because the men doesn't move relative to the boat, and the velocity of the boat. And that will be equals to 0. So, and here we see that we have all those masses. So, and we have then that the box mass is 20, velocity of the box, plus, and this is 200, right? Because it's the man and the boat together. But this velocity of the box is not this one, because this is a relative and this is an absolute value. So what we have in these equations are absolute values. So it's when somebody at short, how they will see the box move and the boat move. So we need a different equation. So this is going to be our equation 1. And our equation 2 will be that the absolute velocity of the box will be the velocity of the boat plus the relative velocity of the box respect to the boat. And this is what is given. This one is what is given. So I have the velocity of the box will be equal to the velocity of the boat. So, and it depends what we want to name positive. If we want to name that this is a positive value, so he will move forward. So we just have to make sure that we know what so if we want to name this as a positive, then this is a positive value, right? So let's name that positive. So we threw the box in that direction because the guy is looking at that direction. So this is a 4 plus 4. So this will be my second equation. Let's solve this system. So we have 20 velocity of the boat plus 4 plus 200 velocity of the boat equals 0. Therefore, we have 220 velocity of the boat equals to 80 negative, right? So at the end, velocity of the boat is equals to negative 0.364 meters over second. And it gives me a negative value, which means that meanwhile the box is moving in this direction, the boat is moving in that direction. So this is the velocity of the boat. So we were able to find the velocity of the boat. This is an absolute value. And then we want to find how far does the boat go. So this will be step 2. Once the person loses the box, so he's riding the boat, right? And there is no impulse due to the water because we said that the water doesn't create any resistance in this case. So he's moving at a constant velocity. So the boat will move at a constant velocity. So we can apply the principles on momentum again, and we'll see that since we don't have any impulse, the boat will be moving in the same direction constantly. Obviously, that's not the truth because we do have a resistance of the water, but we can neglect it for a very short period of time, and we could get an approximate distance where he will be moving. So you remember that the velocity is the derivative of the distance. So if we integrate both sides of the equation, and since this is a constant, we just will have that the velocity times. So we integrate both sides of the equation, right? And this is a constant, S0 is 1, and we will get that the velocity times is equals to my displacement. Therefore, my displacement in 3 seconds will be just that velocity of the boat. And if I keep the sign, it means that it moved backwards, right? Times 3. And that will be equals to 1.09 meters. So we were able to find how far does the boat goes in 3 seconds after he releases, the man releases the box.